In our calculations up until now, we've always assumed that all reactants are converted to products, but this is not always the case. In this video, we'll be looking at yield calculations. Now, the story so far in our stoichiometry is that we've always assumed that you will get 100% conversion. So if you have 100% conversion of reactants to products, this is what we call a theoretical yield. So if we want to work out an actual yield, we take the actual quantity that we have been given, we divide it by what the theoretical quantity should be, times it by 100, and this will give us a percentage yield. Now, the greater the percentage yield, the greater the conversion. Now, the most important step when doing a percentage yield is being able to identify if the known is the reactant or the product, because it changes how you do the problem. If the known is the reactant, then when you do your stoichiometry, you're calculating a theoretical quantity, and then you apply the percentage yield. If, however, your known is the product, then you've actually got an actual quantity. So at this point in time, you apply the percentage yield before doing the stoichiometry. So let's try an example. We've been told that ethanol can be produced industrially by reacting ethene with water. If 150 grams of ethene, now ethene, CH2, is our known, and it's a reactant. Reacts, calculate the mass of ethanol. Here's our ethanol, and that's our unknown, if it is 5% efficient. So the most important step, remember, is to identify if our known is our reactant or our product. In this case, it's a reactant. So we're going to apply the percentage yield at the end. So we're going to do our stoichiometry exactly like normal. So we're going to find the number of moles of ethene, which is equal to a mass over a formula mass. The mass of the ethene is 150, divided by the formula mass of 28.052. Now this comes out to the number of moles of 5.347 moles. Now this is in a 1-to-1 ratio, so 1 mole of ethene will produce 1 mole of ethanol. So the number of moles of ethanol is the same, which is 5.347 moles. Now please note, I always make the statement so my marker knows what I'm doing. So now I can find the mass of ethanol. And this is equal to a number of moles times a formula mass, so it's 5.347 times 46.068. And this comes out to 246.335 grams. Now this is if we had 100% conversion. So this is actually the theoretical quantity that we would get. So now we need to apply our percentage yield. So now let's apply our percentage yield. So we know that the yield is equal to the actual quantity divided by the theoretical quantity times 100. So in this case, the yield is going to be 5%. So that's where we put the 5. We don't know the actual quantity, but we do know the theoretical amount we should be getting, which is 246.335 times 100. So rearranging, the actual will equal 246.335 times 5 divided by 100, which equals 12.3 grams to 123 significant figures. Now let's look at the same problem with a different starting point. In this particular problem we have 150 grams of ethanol. So our known is our product. Now because it's a product, this is the actual amount of conversion we got. And that was 5%. So this is representing 5% conversion. And before we start the stoichiometry, we need to know the theoretical or the 100% conversion. So we apply our yield calculation at the beginning. So our yield is equal to actual divided by theoretical times 100. So our actual amount was 150 grams. That's our actual product that we got in hand. Our yield was 5%. We don't know what we would have got if we had 100% conversion, and that's what we need to find to start this problem. So rearranging the question, the theoretical will equal 150 times 100 divided by 5. And this comes out to 3,000 grams. Now this is pretty logical. You'd expect there to be a lot more if it was 100% conversion. So now that we've got the actual theoretical amount of product that we should have got, we can now do the stoichiometry. And the stoichiometry is the same as normal. So the number of moles of ethanol will equal a mass over a formula mass, which is 3,000 divided by 46.068, and the number of moles comes out to 65.121 moles. Now this is still a 1-to-1 ratio, so the number of moles of ethene being a 1-to-1 ratio will be the same, but I still make that statement, so my marker is my friend. And therefore the mass of the ethene will equal number of moles times formula mass, which is 65.121 times 28.052. And this comes out to 1827 grams. Now our question was in 1, 2, 3 significant figures. So this will come out to 1.83 by 10 to the 3 grams. Now you need to go and try some yourself. So if you go to the OneNote, rates and equilibrium, calculations ones, questions 7, 8 and 9 have all got percentage yields. Also Pearson 12, 11.1 has percentage yield, and Stawa set 31 also has percentage yield.